Yeah. All right, we are ready. Hi everyone. Thanks for coming. We are glad to have you here. We are very excited. It's our first developer event in our new venue. So this is our new home for 3 years, unless the landlord kicks us out, but hopefully it's gonna stay until the end of the lease. So for 3 years, we're gonna be here. We're gonna organize a lot of events, workshops, meetups, mini conferences. I think we can hit like 200 people seated here. So yeah, you're gonna hear about us soon. So just for the ones who are new, so the AI user group, so I'm Cyril. I'm part of AI user group, and we are here to train professionals on AI technologies. We have one track for marketing, one track for developers, and one track for design. We are running these events every month, and we are looking for speakers every month. So if you are working on anything interesting, it doesn't have to be an actual product. If you have just like, you know, you're working on something that involves AI and you find that interesting, or also you tried something and it didn't work and you want to tell us why and what did you learn along the way, we are really keen to have this kind of talks. So please ping me, Cyril, Cyril, at aiusergroup.com. First, we're going to start with a short video from our co-organizers. So it's a platform called n8n. Who heard about n8n before? 3, it's not a lot of people. Okay, so it's a no-code platform, very cool, it's open source, you can host it on your own environment, and our friend will tell you more about this. Actually, I need the sound, so let me put the sound back.
Hi, I'm Max, developer advocate at n8n, the automation platform for technical teams. In this example, you're seeing I've got some nodes on my canvas. Each node executes and passes its data along to the next node. But what I'd really like to show you is our new advanced AI functionality. In this example, I've created an AI assistant that helps me interact with my Google Calendar and lets other folks book an appointment with me. So how this works in a nutshell is this agent has various dependencies that it needs. It has the LLM itself, it has some memory so it can handle multiple conversations at once or multiple threads in the conversation. And then it has various tools to understand how to fetch availability in my calendar and to book that appointment. So let's do a quick example demo of this, and then we'll see how it works. So let's see when Max is available next Tuesday. So what my AI agent is doing now is it's understanding them asking for availability, and so it's using the tool to fetch my availability. The agent knows when today is, so it knows when next Tuesday is, and here now it's listed the various slots that are available. Let's book something for 4:30 p.m. Okay. And so my agent is still running at this moment. Great. So the agent, before it makes this request, it understands that it needs my full name and email to complete the request. And so let me specify that. So now that the agent knows that it has all the information that it needs to make the call, it can book the appointment on my behalf. Great, we can see we've got a confirmation here. If I check in my calendar, we see at 4:30 p.m. we booked that appointment. Now, let's see what's happening under the hood. So my chat trigger here is collecting the responses from myself and sending it along to the agent. This is an arbitrary step, right? So this could be a webhook trigger, this could be your own custom trigger that you've coded. That really can be anything that you'd like. It pipes the message into the agent, which then interacts with its various tools. In the agent itself, I have a system message. I'm letting it know that what its task is, and I'm also giving it what today's date is, and that appointments are also 30 minutes. I myself am not a prompting expert and wrote this rather quickly, so you don't have to be an expert to start getting value from this. And then the magic really happens in these HTTP request tools. So each one of these tools allows my agent to consume an API input and understand how it works. So we've got the get calendar availability tool, and we've got the book appointment tool. So setting one of these up can literally take a minute or two. As you can see, I've described very simply when it should use this tool. Call this tool to book an appointment in the calendar. I then define the endpoint that it should consume. I define the credential to use if necessary. Since we have Google Calendar credentials in n8n, I'm using a predefined credential type, but I could also use a generic one if it's something like a proprietary system that you're connecting with. And then from there, I'm essentially defining the payload to send in my body. And as you can see here, I've got some static parameters. These are the things that I don't want my LLM to manipulate. And then I have placeholders for the things that I do want it to manipulate. And as you can see, I can blend static text with these dynamic parameters that I'd like the LLM to control, or my agent to control rather. And then if I want to, for added control, I can, for these placeholders that I've defined, I can add some more definition on how the AI should interact with those parameters. So there can be a description, and I could even define the expected data type of that. So again, I'm constraining what my agent does, so we have more predictable outcomes when we ship this to production. So from here, I could add more tools, of course, depending on what I need my agent to do. There's various off-the-shelf tools to understand the world or perform math, etc. I can interact with an arbitrary API endpoint. I could write a tool in code, and I can even call other n8n workflows. So this workflow that you saw over here could be consumed by my agent. We have hundreds of native integrations, so it's a really fast way to get your agent interacting with the tools and services where you have valuable information that your users, customers, etc. might want to interact with. I'm Max from n8n. We've just scratched the surface in this demo, but make sure to check us out.
So actually, I made a terrible mistake. It's not a no-code tool, it's a low-code tool. All right, and then we're gonna have, is Naya here? Yay! Hey, Naya. How are you? Great, great, great. So Naya has some stuff for you. It's fine. It's okay, it's okay. Yeah, we're good. You're all set. Yeah, you can come, you can come.
Yeah, perfect. All right, everyone. Other than my explosive introduction today, I appreciate you joining me today. My name is Naya Macklin. I am a senior developer advocate at this company called Neo4j. Has anyone heard of Neo4j before? Hey, I love it. Okay, a couple of people. Exactly. No, that's awesome. So I'm just going to tell you all just a quick little thing about Neo4j. If you have not heard of us before, we are a graph database. Has anyone heard of graph databases versus regular database before? Okay, a couple hands. Awesome, awesome. But for a graph database, you traverse things that are called nodes. And those nodes have things that are called relationships. So you could describe a node as a person, place, or thing. Could be a noun, for example. I could be a node. And then I have a new relationship with the newfound camera person where I've tried to mess up his entire situation. But that is our relationship between us. So we're both nodes, and we now have a relationship. So that's just an example of a piece of graph databases. But today, we are proud to be sponsoring this meetup today, the AI for Developers meetup. Neo4j is based out of San Francisco, so we're local as well. And we have an incredible raffle for you all as well. Just because we're trying to support the community, we have a raffle. So this raffle is only for people who come to our physical meetups, our local meetups that are in person. And so you'll enter this raffle. If you scan this code here, you can win a DJI Mini SE drone. So feel free to take out your camera and scan the code. You win, and I'll step out the way for you all. You'll win a drone. We do a drawing once a month. And again, this is only for people who come in person to our events. And we don't have many of them, so you have a really good chance of winning. And if you win, we're going to send you that drone in the mail to your house. No need to no need to lug it around. So we'll send it to you for free. And then, lastly, as well, I just wanted to tell you all about our completely free online developer conference, right? Completely free. So this is a developer conference that we do because we are part of the community, right? The developer community, where I'm a software engineer myself by trade. And we have a number of different technical talks, about 145 different technical talks. You scan this barcode and you can register for the online conference, and it's happening on November 7th. We have a keynote as well by Ben Lorica. Has anyone heard of Ben Lorica before? Okay, that's fine. I see one. But we have an amazing keynote and a number of different tracks. Applications and APIs, AI, which I know is very big right now, knowledge graphs, and data science. And 75% of these talks are all from the, not necessarily local, but all from the developer community. They're not Neo4j talks, they're talks from people like yourself, right? Talks from myself if I wasn't employed at Neo4j, right? So it's just different people giving talks on technical concepts and doing deep dives into those. So it's a great way to learn, a new skill, and it's all one day and happening for 24 hours. So feel free to scan this. Register is completely free yet again, happening for 24 hours on November 7th, and we hope to see you there. I'll make another pitch for it right at the end of the event. But thank you so much, everyone. Again, my name is Naya, and I'm from Neo4j. Thanks so much.
Woo, well done, Naya. That's great. All right, what else? Agenda for today. We're going to start with Daniel right here, talking about making vector search work with complex data. Then we're going to have Vishaka with a talk about how a purpose-built database for multimodal AI can save you time and money. And then just for the folk here, not for you, LinkedIn audience, we'll stop our live stream there. But Ivan will present a new feature of Gemini, a multimodality and long context RAG. And then we'll end with Sam, who will talk about making LLMs reliable. And then we'll have a community open mic. So this is your opportunity to present something to the people here. Usually people use this medium to talk about hiring, or if they are looking for co-founders, or if they launch something and they want the community to try out. Also, if they have an event. So anything you have in mind, think about it. 8:10, sorry, this is your time to present it. And then we'll end with networking and our well-known pizzas. Doors will close at 8:50. We are pretty serious about this. All right, first, Daniel, he's ready. He has been ready for an hour. Making vector search work with complex data. Daniel, it's your turn.
All right, thank you. All right, hey everybody. I'm hoping this can be interactive, okay? So first talk, you are not asleep yet, right? When I ask a question, think about it and raise your hand or give me some kind of feedback, okay? What I wanted to cover today and talk about in general relates to vector search. So maybe the first question to kick us off, who heard about vector search? Majority, okay. Who tried to build some kind of vector search based system? Okay. And who has it running in production? Okay, so we went from about 60% to about 6 people. So let's say we can conclude that vector search is not a solved problem yet. And we have been working for a few years on actually figuring out what's wrong with it and how you can get it to production faster, because if you are one of those people who is trying to do that, that's the kind of stuff that gets you promoted, right? And at the end of the day, that's what we are all trying to do at our job. Cool. Maybe to kind of motivate the topic, there is kind of like a pretty big divide right now. There is big tech using vector search for many years. Many of the experiences that you interact with every day are powered with vectors. And all of this stuff runs on custom trained models, right? So companies are training models to turn their data into vectors for recommendations purposes, search purposes, anything from matching users to ads, fraud detection. It's all custom models. Okay, so that's the kind of people who run this stuff in production. And then you have the rest of us, right? Who pick up a vector database, right? And they try to make it happen. If you have been looking into vector search, you might have noticed that there are quite a few vector databases out there. And so the first resource I wanted to share with you is a table that our community is managing that right now compares 44 different vector databases across about 40 different features. Okay, so if you thought that you know about 6 and it's like way too many, no, there is like way more. They differ on all kinds of different features. This is a part of our solution to help you figure out, okay, how should I even compare these things? And so, that's kind of the place where the vectors go. Once you have turned your data into vectors, these databases help you index this data and find similar vectors quickly. Okay. All right, so vector search is important. It's powering many experiences we interact with every day. In terms of once you have these vectors, putting them into a database, there is 44 different databases, so we are covered, let's say, on that front. What's the missing piece? And that's what we will talk about today. We are, just maybe a quick word about who we are, right? Why do I care about vector search? I'm one of the 2 co-founders of Superlinked. We are a San Francisco-based company with somewhat of a distributed team, but I'm based out of SF. We raised $9.5 million seed round, announced it earlier this year. And we work with vector databases on making vector search work. Okay, so our first 2 partners on the database front are MongoDB and Redis. You guys might have heard about, at least that the databases exist. You might not know that they actually also do vector search, right? So it's, there are vector search startups, and then there are all basically your traditional database that you have been using for many years, probably now also added vector search, right? So no matter where you look, the feature is there. And then the last remaining piece is, okay, how do we make good vectors, right? Because that's the thing that makes a difference between the results coming out of vector search being relevant or not. Okay, so I have 3 problems for you in terms of what's broken about vector search, we think. The first problem relates to metadata, right? So you might have heard about, and listen to these 3 problems, because at the end we'll vote. We'll vote about which one is the most serious. And if I don't cover something you have encountered, then I'll let you shout out what your problem with vector search has been, okay? So this is my first one, metadata, right? If you think about the query like that, popular pens, okay? You are an e-commerce, you sell clothes on the internet, you have a search box in there, okay? And people come in and they type popular pens. Okay, which pants are trendy, what should I buy? How would you serve that query with vector search? Somebody who raised their hand that they tried vector search, how would you, let's say you have a database of products, right? You have product descriptions, maybe product name, right? You have some text information about the products, but this query wants popular pens. How will we build that system that does that?
Yes, we have someone.
User rating, based on user rating.
Okay, so you'll collect ratings, you'll maybe collect how many people buy which pens, right? So you'll have this number. For each product, you will keep track of how popular the pens are, or each product, right? And so you have a number, and then you have for each product, and then you have a description of each product, right? And so what then? Where does the number go?
Well, I think you're optimizing, if you're looking at user rating primarily, you're optimizing for highest rating that's viable, meaning that there's like some depth there.
So how would you construct, how would you put this kind of data where you have the popularity signal and the description into the vector database? Like, what would the popularity be? And, like just a hint, it's like the word highlighted.
Some kind of nearest neighbor search that involves rating and pants.
Yeah, that's right. And if you look at the vector database, it allows you to do a nearest neighbor search in the space of the descriptions, right? Text search, but the popularity is kind of handled a little bit on the side, right? It's a number you can filter by, let's say. So
it's ambiguous, yes.
yeah, you can filter by popularity, but for that you need to somehow understand the query. You have to tease apart the fact that, okay, this user wants filter on this metadata, and then they want proximity on how much of a pens the object is, right? So the treatment of the query is like super not obvious, because the database gives you the ability to turn this whole string into a vector and then do a similarity match, right? But the word popular references metadata, which is disconnected from the description of the product, right? And you can like re-rank, you can filter, but it's it's sort of like not fully integrated, the metadata aspect of the data. Anybody has like sort of like, am I making some degree of sense? Yeah? Yeah?
I was wondering, I use metadata. I didn't understand it. I used it about maybe first website I designed, GeoCities. And the way I use metadata was because my name was Raj Kumar, and every time people search me on Yahoo, I came #1 in San Francisco. So I was on top. So just people say Raj Kumar, so I come up as Raj Kumar in San Francisco. But later on, after 1 year, the Yahoo Mail, GeoCities became Yahoo Mail, and then it became, Google Mail. Then my name disappeared from the query. People say Raj Kumar, they didn't find me on #1 page.
Right.
So what I did was I tried to use metadata, where I tried to define myself in different ways.
Okay, so search is hard. Okay, problem number 1, metadata. I just realized I have to like speed way up. So let's keep going. The problem is that, let's say half of your database is pens. You can't get all the pens out of a vector database, or all the things kind of relevant to the term pens, and reorder them by popularity, because you'll be pulling half of your database out into your application server. So re-ranking kind of doesn't work, and filtering doesn't work, because what is popular? Is it 3 stars, 4 stars? That's hard. So think about it. How do you integrate metadata handling into your vector search? Problem number 1. Problem number 2, this kind of query. So let's say you are building RAG for helping support agents, and support agents often have some kind of manuals, and those manuals contain complicated information. And so let's say they would want to run a query like this: how to assemble the burner. And let's say that the document that has the information looks like that. Okay, somewhere in there is a burner, it has some parts. How can vector search help answer this question in this case? And to know what the problem is here, you also have to know that normally the way vector search is done over documents is in 2 steps. First, you OCR the document, you pull text out, and then you index the text. Unfortunately, this OCRs very poorly. And so, this is how it looks. It gives you a list of parts, and of course, the important information of how those parts relate to each other is lost, right? And so you will not be able to answer the question, if you just treat the documents as text. This is the problem number 2. Of course, it's not just manuals for HVAC systems, but it's also present in any other domain. Once the document gets a little bit complicated, if you try to pull the text out of it, you will fail. And the problem number 3 is the infrastructure around your vector database gets complex over time. You need to, you start with your data, you want to update the database in an ongoing way as the data changes, right? The popularity counter on your pens increases, you want to update it as fast as possible. But maybe you are loading historical data, so you want your batch pipelines as well. You want to process that data, create some Spark jobs, right? Eventually make vectors, put them into a database. You have a query server running on top of the vector database, and your application up there using the query server and feeding data, sort of clicks or thumbs up, down, back into your data warehouse. So when you build vector search systems, they get complex over time. And the problem with that picture is that you control kind of each of those steps separately usually. You have data engineer writing the pipelines. You have, let's say you are building your own query server, and that basically desynchronizes from the pipelines. Basically, it gets complicated over time, right? So how do you control all of this? That's the third problem. So metadata handling, trying to pull text out of documents and failing, and complicated infrastructure, we think are the 3 main problems with making vector search-based applications work. From the people who had the hand that they ran something in production, any other problems that you encountered that you want to share with us? Okay, did I cover your problems, or you didn't have any problems? Okay, or we are shy. Maybe that's the last option. Okay, so I'll not, torture you any longer. There is a framework for this, right? That solves all these different problems. If you build something with Superlinked, I'll reshare your creation, okay? I have 20,000 followers on various social media platforms. If you are looking for a job, if you are experimenting with AI, you build something with Superlinked, email me at daniel@superlinked.com, and I'll give you a shout out everywhere, and I'll help you get out there. So it all starts with pip install Superlinked, as it usually does when you build with Python. It's open source, free to use library, and it solves the problems I described. You start with playing with this in a Python notebook, for example, or your local script, and for that the library is enough. It kind of looks like this. It kind of looks like a ORM for a vector database. You define your data objects with this kind of schema annotation at the top. You define your index, you define how both the text and the rating, right, gets handled properly, gets vectorized. That's what I meant by metadata is being handled properly. And at the end, you can do your query, popular pens, and get results out of the database that are both popular and pens at the same time, without re-ranking, without filtering. You just get popular pens. What if you want to run this as a service? You install our command line tool and write superlinked run, and now you get API endpoints on a local service that you control in the same way as the library, so it's reproducible. You can push data into it, you can run queries, and it manages the underlying vector database. Okay, so if you thought, okay, I don't want to kind of learn how to work with the vector database, now you don't have to, because Superlinked manages it for you. Index construction, all the configuration, putting data in, running queries. It's all done for you, and then you can switch to different databases and you can explore. Oh, this one is faster. This one is cheaper, right? You can figure out what fits your use case. Our first 2 partners are Redis and Mongo, but we are adding more. And then finally, okay, you work at a big company, you have millions of data points, you want to make a lot of vectors, and you don't want to run this on your local machine or on one computer in your cloud, Superlink deploy, right? This orchestrates that complicated diagram I showed you before with the batch pipelines and streaming updates and all of that in your Google Cloud account. That's how we started. It runs in your Google Cloud. You have full control over it. You don't have to trust us with your data. Kind of looks like that. That's what you'll get when you do Superlink deploy. As I said, handles everything for you. And that's it. So just a quick summary. That's our GitHub repo, right? So if you go to GitHub and search for Superlinked, or you go to superlink.com and click on GitHub icon, that gets you to the repo. If you build something with Superlinked and share it with me, I'll make it worth your time. And we would love your feedback as people who are experimenting with vector search and trying to get it to work, right? Lots of people raise their hand that they have been playing with it, but so few hands actually use it, right? So our goal, we are 22 people, mostly ML engineers. I was ML tech lead at YouTube in YouTube Ads for 6 years. So we are working really hard on making vector search work. And we would love your feedback on how we are doing and what the use cases are you are working on and how can we help you do it better. So that's my email. That's the GitHub repo. And yeah, that's it.
Nice. Thank you, Daniel. Okay, I think we have time. We have time for one, maybe two questions. Who has one? Yeah.
When you were talking about problem 2, about like the image and how you were, I guess, parsing it, OCRing it.
Right.
I worked at a company and we were taking abstracts from research papers to search through them. How would you do that like with an image? Because we were not able to solve that problem. We were like, okay, let's just take the easy way out, look at the abstract, and just run with the abstract, because that's just text. How were you able to, individually, like without, like at scale, go through like tons of images and push them to the database in vector form?
So maybe just a quick summary. How can we do it without just pulling the text out of the documents? How do we get our vector search actually understand the picture? And the first signs of this actually working were the OpenAI Clip model that can turn images into vectors, but is trained more on images of everyday things, right? So you can search for cat or a dog or a whatever table, right? And you could prompt the model by text, but it can also encode image into the same vector space. So this has been possible for more than a year now, or yeah, maybe 1.5 years. And of course, there are many open source fine tunes of that model, and there is Fashion Clip if you are in fashion e-commerce and you want to distinguish between t-shirts with long and short sleeves and so on. But that family of models doesn't really work on pictures like this, right? Pictures like this contain some amount of text and a complicated structure. And it's basically this summer that in sort of open source research, models became available that basically the way they work is you take a page, you treat it as an image, you slice it up into squares, about 1,000 squares, like a lattice, and then each little square of that page gets a vector. And those vectors encode basically what's on that page without taking the text out. And those models, just think about it as a model that has kind of the vision part. It can consume the image, and then it has the language model part. And so that's the part that also allows you to query it with text, right? And so it can project this kind of page into vector space, and it can also project a query that's textual into that same space. And through that, you can find out of a big set of documents the 5 pages that are relevant to, let's say, burner stove assembly. And then you take those 5 pages and together with the question, you feed them to a vision-capable, like GPT-4o, for example. So you give it the query, the 5 pages, And then without extracting the text, even at that stage, the model kind of looks at the 5 pages, the question, and produces an answer. So at no point in that whole pipeline you are pulling text out from the page.
We're out of time, but he's gonna be available during networking.
I need to ask you, OCR, is it optical character recognition?
You got it right. Yes, yes, yes.
Cool. All right. Cool.
Thank
Thanks
you
for
very
the
much.
short answer.
If you have any questions, just hit me on email, find me on LinkedIn. I would be very happy to help you with your vector search troubles.
And let's give Daniel a round of applause. Great presentation, great explanations. So next, it's gonna be Vishaka.
That's going to be one tough presentation to follow. But thanks, Daniel, for making some of my life easy on explaining some of the problems here. You kind of covered the first part of my presentation. All right.
It's teamwork.
No, that's not the... Where am I? Oh, I got it. This is the one I tested it with, right? Yeah, okay. I think I got it. Oh, got it. Yes, thank you. All right. Hi, everyone. Thank you so much for being here. Daniel covered a lot about vector search, and that was like a big part of what I was planning to talk about. So now, what I'm going to do is go a little deeper into the challenges that he already started talking to you guys about. So hi, I'm Vishaka. I'm the co-founder and CEO of Aperture Data. And yeah, we have built a database specially for multimodal AI. And let's go see what that means, how we came about it. We started working on it back when my co-founder and I were at Intel. So yeah, it's been some time trying to figure out these problems and experience all the things that he talked about. I just didn't answer his questions because that would have stolen the thunder in my talk here. All right, so let's talk about building the right data tools for multimodal AI. And I always find it easier to start with some use cases. And I'm going to start with a more traditional machine learning sort of use case. So we've been working with a visual AI team with an e-commerce vendor for quite some time. And the biggest thing is like, can we recommend products that will make customers want to buy? And our buying habits are more visual. Like you look at something, you like the color, shape, pattern. But it's not just that. You want to recommend products from the recent catalog, and then you want to show the actual images. So the first part is finding similar by color or shapes or patterns or anything. But then you have to go constrained by, OK, I only want fall 23 catalog, and then you access the image. So there's the vector search, followed by the metadata, followed by the data access itself. And even before people can get to that, we are talking about indexing all that image data, creating the embeddings out of the images. In fact, before you can index the embeddings, you first have to train the models on your catalog so you actually can create embeddings that you care about, or in this case, these guys had to care about. And then you index the embeddings, you correlate everything together. So that's one use case. The other one is the use case that we have all now been coming across, chat support sort of use case. So what does error XYZ mean? What does it mean for equipments made between 2022 and 2023? And anytime you get the manual for the equipment, you want to limit it to manuals authored by Team A. And you want to see the manual, of course. So again, we are talking a real-life problem with similarity search constrained by metadata filtering and followed by PDF access. So you see the theme of where I'm going with this. So in general, you need the ability to index and search over high-dimensional embeddings from any number of multimodal data types. So it's not just text. It can be text, images, videos, PDFs. And then you want to combine it with metadata filtering and retrieving the corresponding data. And not only that, when you are deploying this in production and you're doing this at scale, you need high throughput, sometimes low latency. The metadata is constantly evolving and often very rich. It's not just one or two columns. It's a whole sort of relationships, and we'll see some examples. You want to be able to get to the original data because you're doing all this search to find the data you care about, and you want this reliable, scalable, and if you're working, particularly in a big company, there's all these constraints around, enterprise ready, cloud agnostic, can it be deployed in your virtual private cloud? So these are all the requirements we are placing on the data layer. But if you look at and I think this is something that we all just saw, vector databases today, they'll let you store the features, they'll index them, they solve a very complex problem. And oftentimes you can attach some metadata to each vector. But most of the times you have to carry the ID around to correlate it with your original data and any complex metadata. So you're missing complex graph-like schemas, which is what real applications end up having. You're missing the capability to manage the multimodal data itself. And it's rarely built to integrate with the overall AI pipeline. AI pipelines don't just start and stop at LangChain or Llama index sort of level where you're just querying the data. They start from the point where you collect the data, index the data, curate, sometimes label, and they go, and that's when you come all the way to the query part. And not to mention all the choices you have to make around whether it's cloud, which cloud it's supported on, is it scalable, can it support all my enterprise requirements? So what do people get today? And I think this is going to be a much uglier picture of what we saw in the previous talk, because what you start out with is data input. It can come from your own assets. You could be recording constantly from sensors. And what you really want to get to there is on the side. You want models to deploy. You want data to show. You want to see. You want to do recommendations or build LLM and RAG-based applications. But your data backend choices suck. You're going to ingest the data, typically put the large files into cloud buckets or some distributed file system. You're going to pick one of the databases to put your metadata in. If your application requires some form of labeling, you're going to be dealing with how do I pull my data out? How do I land my labels in? How do I make them searchable? And that's when everyone in the different teams will be writing their queries to pull information out of these different pieces. And God forbid, if you're working with image video type of data, to bring them in the format you can use them, very often you have to work with hard to install and hard to use computer vision or audio processing libraries. And then after that is where you get to the stage where you have your embeddings that you can index in the vector database. So what really ended up happening, even if you were choosing the right tools for the right data types, because of the problem we are solving with multimodal data input to produce human-like AI output, you end up with this spaghetti-like solution, which, as you can imagine, is a pain to install, awful to keep up to date and maintain, and really, really painful to debug when something goes wrong. And that's why people end up spending so much in their resource cost. There's so much lost opportunity cost because you spend so much time assembling this, and then when you get into enterprise problems, data governance becomes a problem. Now, dare I ask how many of you have actually felt this sort of pain in trying to set things up? Thank you. A few. But that's where you're headed if you're deploying AI in production. So how do we solve the problem? So what we realize is really at this point, we need to bring different data types together, which means you need something that understands the complexity of data management and the requirements of AI pipelines. So first thing we addressed was the data itself. So Aperture DB allows you to manage multimodal data. Why did we not leave this in cloud stores or file systems or data lakes? Because this is what you get. Somebody wants a specific data set. They will go download it on their specific local machine. then you start losing track of how was that data processed, where was it downloaded, how many times was it downloaded, how much storage is it occupying. Sometimes you may have permissions, sometimes you may not have permissions. Is your machine powerful enough to create that data set locally? And so ultimately, if you are using and trying to use all this data for producing good AI, the outcome is really subpar. And so, and this is text-based. Imagine the pain with images and videos. Then the second thing we realized is the metadata in a lot of real-world applications looks like a graph. However, graphs used to be slow because of all their connected nature. So that's why we decided to go with a memory-optimized property graph that we built back when we were at Intel, and then we had a second version during our time in the last couple of years. And why did we go with a graph database? Let's take a look. Typically, this is just like a claims and insurance sort of example. There is freight connected to the carrier, the claims they are making. All of this information is connected to each other. And the queries tend to be, okay, well, I want to find all the freights managed by carrier named Trucking 409. And most of these things have, like, in your relational databases, you'll do foreign keys. In key value stores, you'll really have to bend backward to represent all this information. Then let's take another example of retail. The customer walks into a store, you have cameras recording videos and stuff. Maybe you have interesting clips that you want to find out. When did someone pick up a cereal box? Maybe you want to create data sets that later on you're going to use to train your models. We looked at a lot of real-world applications, and the schema invariably was in the form of a graph. So our thought was, if we can make a fast, scalable graph, that would be the right database for storing the metadata. And that's what we did. We built a new graph database, low latency, scalable to billions of objects, and high throughput to integrate seamlessly with Aperture DB. Then the last big piece was vector search. We started working with images and videos first. And so one of the ways of finding this sort of data was through embeddings or signatures. And so that's why we built a vector database with it. We introduced it's based off of Meta's Face library, so it has a flexible API. We support different indexing algorithms, and as of some customer measurements, we are 2 to 4 times faster in the way we built this. So putting all of this together, we didn't want users to actually have to talk to multiple solutions, so that's why we built a query engine that unifies all of this. So as users, whether you are querying the metadata or doing vector search or fetching the data, you're talking to one system with a one unified query language, which is why we actually let go of SQL interface, and we built a query language that we define because we wanted to combine all these different artifacts seamlessly. And so that's how we give you a unified backend for multimodal data. You can do different searches, data management, and then you can work on different. So essentially, what we really want to do, and what Aperture Data brings differently, is you can use all your data across your entire machine learning workflow and achieve the results you are looking for from your AI efforts. I'm going to skip some of the performance and all these things, but I want to come to the title, like, does it really make a difference? At least for the e-commerce example, a team of 10, you're looking in productivity gains about 2 million in savings, and keeps growing as it grows because of the time you save for the data scientists and the access you give to them. Same way, we worked with this retail company that scans shelves, the robot scans shelves, and they are figuring out inventory. And what we were able to offer them is much faster, high throughput vector search for this application, and they have been able to scale to more than 300 stores, which indirectly impacts or directly impacts how many stores they can keep growing to. So now let's look at, did we really simplify the life of data scientists and engineers as we started, as our initial goal was? So how many of you guys here work with just text? Images, videos? Awesome. So one of the things we recently did, and I will try to switch here. You can now, we recently launched our database on the cloud, so you can go to cloud.aperturedata.io/sign up and create an account. And what you will be able to do from there is just create your demo instance, choose from one of these providers. You can start out with our free plan. And then you'll be able to run our quick start example. So what I want to show you here, so if I go on my notebook, I'm just going to activate my cloud connection. So we have, of course, I care a lot about food wherever I go. So our sample data set is based on food images. So you can, if you start the quick start from our cloud, you'll be able to just configure. I did all that stuff. I'm just going to connect to my ApertureDB instance. So we have the database that runs, and then you can do pip install ApertureDB, which will install the client. And then you can essentially import ApertureDB and some utilities, connect to the database that I've already configured. Now, I have already ingested the cookbook dataset, and what it has, let me actually show it to you on our UI. It has, so if you search, it has some number of food images. So I ingested them, as you can see, with some metadata on the side and the images themselves. In fact, you can go on this dashboard and see what the graph schema for this is. We ingested ingredients, images, and descriptors is what we call embeddings. And so in this example, we have ingredients, images, and descriptors, and the relationships among them. So this is the data set we ingested. You can see the summary here. So I won't run the ingestion here, but one comment that I want to place here. What we did was we defined the dishes in a CSV file, so just all the properties you want and the image files themselves. You run an ingestion, and you can apply. So in the earlier talk, we heard about clip embeddings. So that's something we run quite often, and you can run any model here that will help you extract embeddings from the data type that you're ingesting. And what that did, not only did it add images to ApertureDB, it actually added the metadata and the clip embeddings corresponding to that image to help us create a graph schema that looks like this. So we ingested in that small data set example just a subset of this, and that's essentially the image, which is the dish that we added, the ingredient, and its descriptors. And so if I were to start running some queries, now assuming this is going to work live. Oh, it did. So what we are looking for here are, images that are from Scottish cuisine. And you did the metadata query and fetched the image from the same database. In fact, this is what I was talking to you about, our own query language. We define entities, images, objects, and then you can do graph traversals on them. I don't have time to go into how it works today, so let's just assume it's going to work. And what we are really looking for are images and information of dishes where you have butter and chicken at the same time. Now, I know we are getting closer to food time, so bear with me. This is on purpose. And so what we did was we actually went, we found 2 different ingredients and found images of dishes that contain both the ingredients in them. And so that's why we got this butter chicken photos. Similarly, you can now do vector search, and you can say, okay, find me dishes that look similar to bread. And in fact, in this case, we are asking it a text question. We are saying, I want a photo of bread. And we are going to use those clip embeddings that we indexed. And what it's going to give us are images that match the photo of bread. And all of these actually, well, this is questionable, but that's where, but this one you can see. So a lot of it, of course, depends on the model, which we don't control. In fact, there is one picture where I look for Scarlett Johansson, and I get a person, like a guy with no hair. But I blame that on FaceNet embeddings. It's nothing to do with the distance that we do. Oh, Oh, wow. See, I even missed that part, so not bad. I shouldn't blame the models just randomly. So yeah, I mean, this essentially, like, this shows you some of the power of how you can manage the different data. In fact, the same way that I'm doing image queries right now, we have indexed videos, and you can run constraints and get videos. You can get interesting clips from the videos. In fact, you can do similar sort of text-based lookup of video clips in your data set. And the power really is that you're bringing all of these different data types together, which is where, if you look at where the multimodal AI, like all the work that we are doing is going, you're gonna need all these different data types, and you really don't wanna have to talk to 5 different tools to get them together. And so that's what we are offering with Aperture DB. In fact, if I go to my documentation chatbot, I asked it, like, so we built this chatbot using our LangChain and Aperture DB vector search integration, and I asked what's multimodal data. It tells me you want to combine these things together, and we have indexed, of course, our documentation and use this. So yeah, I mean, that's essentially a quick overview of what we see with with Aperture DB. And I wanted to show you a combination. So, like, we in another data set, we have celebrity faces that we indexed. You can search people with black hair, and this is what I meant with the FaceNet. Look at the match here. But you can combine vector search with metadata here. You can do find k-near neighbors, but filter them by brown straight hair. And what we are doing here is giving it the ability, using the database to combine vector search with the metadata search, which in our case is a graph, because we blend everything together in the graph that we represent things in. So that's some of the examples. There's a lot more you can do. You can integrate with PyTorch, TensorFlow. You can work with Label Studio for labeling. And these are our blueprints. We can work with other tools as required. And yeah, essentially the big takeaway here is, like, when you use the right data tool, you can go from days or months of preparing data and wrangling with your data to minutes of just querying for what you need. Now, for what we would really like all of you guys to do is scan this QR code. We have a contest that's live. We would really like to see you guys go build something cool with Aperture DB, use some partner tools. We are uploading some examples soon, and hopefully next week we are able to do some live event to answer questions. We would really like to see some neat examples that bring different data types together. Thank you very much. Questions?
Cool. Thank you, Vishaka. Do we have questions? I think we have time for 2 questions. Question for Vishaka? No? Okay, I have a question. So if we are only using text, does it still make sense to use you guys, and what kind of value can you bring?
You can still use Aperture DB for text search too. Mm-hmm. It works with all the different metrics and engines that you need, and that's what we do in our chatbot with LangChain. And over time, if you realize you want to index more things, you already have the right database for it.
Cool, great. And why did you choose a different language than SQL or GraphQL?
Yeah, that has been one of our controversial choices, because people are like, why would you need anything other than SQL? And really the answer is, we looked at SQL, GraphQL, Sparkle, and the problem was we were trying to combine a lot of different data types, the ability to search by metadata, vectors, and one of the things I didn't cover in the talk is how Aperture DB has these pre-processing operations. So not only can you say, find me images of Scarlett Johansson, but also say, give them to me in thumbnail size. And specifying all of that in SQL would have really required like a language guru, which we were missing at the time. And we focused more on the functionality. So we bit the bullet, said, okay, we'll define the simplest form of a verbose JSON-based query language so it's easy to follow, and we built it with that.
Great. Okay, one very last question. What's special about the way you are dealing with multimodal data compared to whatever exists on the market?
I think the specialization comes from, like, if you look at the way we can deal with images and videos, because that has been our longest experience, and the text and stuff is, like, we've started working with them recently. But if you are working with images and videos, there are some really challenging operations. For example, with videos, sometimes people only want a little 10-second clip that's interesting, but they have to go get the whole hour video or pre-chunk it to do that. And we have ready operations that say find clip, which you get the interesting clip, but you don't create a copy of that clip. So this is done on the fly, and it's done at the video decode speed, even if you're pulling some little portions of it. So the fact that we are able to manage the data ourselves gives us the independence to do all these, like, to introduce these sort of features. The same thing with polygons and bounding boxes that we provide on images. We are able to do all that because we manage the data as well.
I see. Cool. Well, thank you, Vishaka. Let's give Vishaka a
Thank
round
you,
of
everyone.
applause. And this is how we are ending our live stream. Online audience, thank you for attending. Next time, come in person so you can see the whole show. We're gonna